Alright, we're going to go ahead and get started then. Obviously this webinar is to show you guys some stuff about AcoubatBIM, which is a software we make here at CYPE. But we're actually going to start in IFC Builder, which is what you guys are seeing right now. IFC Builder is just basically what CYPE uses to make to construct our projects and to make all the geometrical elements of any project. So we're talking floors, ceilings, doors, walls, things of this nature. It's very similar to Revit. I'm sure you guys are all familiar with that. So I'm not going to talk about IFC Builder too much. I'm just going to show you guys first the 3D view of the example we're going to be working in. So this is going to be the office building that we're going to run an analysis on in AcoubatBIM. So we constructed it here in IFC Builder. So our first task is to transfer this into AcoubatBIM. And the way we're going to do that is through a medium called BIMserver.center. It's what we use here at CYPE to help coordinate projects and basically help move information and data in between our different software programs as we work. So I'm going to open up. Alright, I'm going to open up BIMserver.center. You should be able to see it now. And it's just, as I said, it's just a web-based medium. So it's more or less a website. You have to have an account. This is my home page. As you can see, you have your projects, which we're going to create a project just in a second to move our data from our IFC file into AcoubatBIM. You also have contacts. So you can share projects with different people, collaborate with different people on projects. People can, here in collaboration requests, people can request to join the projects you've made. You can search for people. And there's a news feed also. Also, you can go here to the store. This is where you'll be able to download AcoubatBIM if you're interested after our seminar. Also, there's all of CYPE's other programs are on here too. So that's enough about that. We'll go ahead and create our project. So it's very simple. You just want to create a new project. Name it whatever you want. I'm just going to name this one example. So there's a couple things you have to define. First is the project type of project, so professional, educational, etc. Pretty intuitive stuff. You have your visibility. This is going to determine who can see your project. So can anyone who has a BIMserver.center account see your project? Can only the people you've contacted? Can no one see your project if you don't want anyone messing with your stuff? And then you have who all can work on your project. So open, anyone can work on your project. Open to my contacts means only your contacts can work on it, and close means everyone has to request to work on your project before they can work on it. So those are all decisions you'll make on a project-by-project basis. You can also add a quick description. So we're going to create this project. So this brings us to the project page, which you can see all the files that have to do with the project, everyone who's worked on the project. You can invite people to work with you on the project. Here's where people who are requesting to work on your project, their requests will pop up. And also you have modification history, which is very helpful. Obviously, if you have some sort of issue, it's very helpful to be able to trace back and see what you've done in the past to try to rectify an issue you might have. So now that we've created the project, we can go back into IFC Builder. I'll close out this 3D view. And we need to export it up here in the top right. We need to export this project and basically put it on BIMserver.center, so then AcoubatBIM can then pull the information from BIMserver.center that we'll then use to run the analysis on this building. So we're going to export. You want to link to a BIM project. You want to select your project. And we're going to select the one I just made, this example. You hit accept again, and it'll export that IFC file. So the export's finished. We're now going to open AcoubatBIM. Once you're in AcoubatBIM, since you are linking to a BIM project, you're just going to create a new file real quick. It doesn't matter what you name it. And then you're going to link it to the project which we just created. So that example again, you hit accept, and now it's going to import all the information that was held in the IFC file. And it's going to put that all in AcoubatBIM for us. Once that's done, it'll pop up with your 3D representation. As you all can see, it's the same building we were working on in the IFC file. And then we'll hit accept, and it'll open it up actually in AcoubatBIM. So here's our AcoubatBIM interface. As you can see in the bottom left corner, as I'm showing you now, here's our 3D model. The first thing I'm going to talk about within this program is up here in the left-hand corner, general data. General data is a very important part of the whole program. It's, for all intents and purposes, it's the heart and the soul of the program. This is where you're basically going to tell the program how it's going to calculate the data and then how it needs to analyze the data for you. So under design options, you basically have these three are basically basic acoustic tests that get run in order to analyze acoustic performance of buildings. And over here, there's different equations, different methods to run these tests. And a lot of the times it depends on what the norm is in an area or what a local law is as to what equation or what test you have to use. So those can be important. You definitely want to make sure you pay attention to those. You'll also have to define your types of spaces. Right now it's empty. We don't have any settings. I'll import settings in a second. But types of spaces are important because clearly you don't need, for example, a stairwell doesn't have to have the same acoustic performance as a bedroom or an office as far as the propagation of sound into that room, into that space. So you have to define the types of spaces. Every single room in the building has to be defined as a space type is what I'm getting at. And you can do that simply by you just click this plus button. You can make your room name, you make a quick reference code, and you can go through and add, you can have as many or as little requirements as you want based on what you need for your specific project, based on, just your personal needs for whatever you're working on. We have here the French and the Italian codes, actually. So if you press either of these buttons, the codes for these countries will automatically be put in the program, and that's what the analysis will be based on. For this example, however, we're going to import our own code. And basically all we're doing here is this default code. As soon as I accept it, it's now in the program. If we click on types of spaces, you can say all these types of spaces now have been added. And basically, this is it's a pretty good feature actually, because if you have a certain configuration that you like and you want to keep using, you can export it and save that configuration with this button. And then every time that you have a new project and you want to use the same configuration, you can just go ahead and import it just like we just did here. So this last part, interaction between space types is important. So we have the receiving room. So if a protected room, for example, is receiving sound from a habitable room, excuse me. These are the requirements. These are the thresholds that you're telling the program it has to meet. So that's going to be obviously important when it kicks out your results at the end and it tells you if you have a problem or not. You just want to make sure everything in this configuration is set up correctly. So enough of that. Now that we know that we have to define all our spaces, we'll look at our spaces. So in this menu, we have our library menu, and just below it, we have spaces. And all these spaces that you see here, the office, the lift, the risers, all these spaces were coded as being offices, as being the lift space, as being the riser space, etc. in the IFC file. So that's where this information comes from. And then from here, we can define all of these as the different types of spaces that we just put into the general data up here. So, and also another cool feature, as you can see in the 3D model, when you click on the type of spaces, it'll highlight that for you. So it's just another way to help you visualize what you're looking at, what you're working with. So, I'm going to go ahead and define these real quick. And but yeah, we wanted to do this for you because this is a very important part of the process and how the program works. So just give me 1 second to finish this out. Okay, so now all our spaces are defined. I'm going to take 1 step back from moving towards what we need to do to run the analysis at the end. I'm going to explain another great feature about AcoubatBIM, and that's right here, this Acoubat library. So the Acoubat library contains over 2,400 different products and over 3,000 different sets of acoustic data. So obviously, when you run an acoustic analysis, you have to have, the program has to know what each geometrical element is made out of, and it has to know the acoustic properties of said element, because if it doesn't, obviously it can't run an acoustic equation, it can't calculate anything. So here is where you're going to find all of the different materials basically you're going to use to define all of the geometrical elements within your project. So there's a couple cool features. First, the database actually includes a lot of products made by manufacturers. So if you look at under this specific floating floor, for example, you can see that there's products that are made by real manufacturers that you can pull from. But also there's traditional products, which are just kind of general products, which are things that you're going to be able to find products that are very similar on the market if you don't use one of these manufactured products, obviously. So the first cool feature about the library is you can search any of the items. So as I said, there's over 2,400 products. You don't want to have to pour through all the different products and try to figure out where what you're looking for is. Where you can just search it here and find what you're looking for and select it quickly. The second cool feature, which actually is very helpful, is the comparison tool. So when you have a product, first page is just going to be a quick description with a couple of characteristics of your project. And when you go over to the next tabs, you have your acoustic properties of that product. But a lot of the times when you're running analysis and you're trying to figure out what product you need to use at a certain spot in order to meet your acoustic goals, you need to compare different products. So you can do that by having a product selected. So this is 17 decibel performance, a carpet. And if you want to compare that with another product, all you have to do is first click one of these 3 icons up here. It doesn't matter which one. And you'll notice that the graph instantly changes. Before it was blue, now it's green. So now all we have to do, if we click on another carpet, let's say 24 decibels, we get that graph overlays the first graph. And then you can compare those and figure out which is going to be best for your specific situation. You can do that again. So since we have the 24 selected right now, we can click this guy, and that blue curve will now convert to red. And if we select another product now, all 3 of them will be on. So you can do that with up to 4 products, which, as I said, is really useful when you're trying to figure out what's going to best fit your needs. So that's that for now. So we're going to have to define all the geometrical features, as I said. We'll start with the facades, the external walls. Just like how all the rooms were defined, what they're going to be with the spaces, such as the offices, the lifts, the risers, all of these are already defined as far as what materials they're going to be made out of. So when we made the IFC file, we knew that all these highlighted external walls, which we've labeled brick wall 13, were going to be of the same material. So we can go ahead and define them all at one time. Same with brick wall 17, which is going to highlight now, and same with the fence on the roof here. So we'll start with brick wall 13. How do we define it? We come over here to base elements. We change our selection. I know what I want to use, so I'm just going to search it. You'll also note that this library is a lot smaller right now, and that's because it only pulls up the products that can be used as facades, which is obviously helpful because it breaks it down for you. It makes it easier to digest the information. So we have what we want selected. We just hit accept, and we can see now it's implemented within the program. So we're going to have to do the same thing with brick wall 17. Again, I'm just going to search it. Accept, and that's implemented. It's also worth noting that you can add claddings, either internal or external, so on either side of the wall. So let's say we want to add an internal cladding to this wall. You just click the checkbox, and it'll activate your ability to select a product for the cladding. You select it. You select whichever one you want. I'm going to go with this Gibson board. Hit accept, and that's also defined. So then I'll just do this fence real quick, and we'll continue. So you would have to go through and do this with all the partitions, all the screeds, all the floor slabs. However, we, in the same way that we brought in our configuration in the general data, we simply did that with the partitions, the screeds, the floor slabs before we started. So I won't have to go through and select all those. I'll save you guys some time. Further though, it's good to know that all of the elements, geometrical elements, don't have to be defined in the IFC file. You can define them here. You could in fact build an entire model within just this program. The only issue is it would not appear in the 3D model. But just for the sake of showing you guys, we'll add a couple of features. So say we want to add some air inlets. All you have to do is select whichever feature you want. You go up to the piece of paper with the plus. Label it however you want. And then define it. Okay, so we're going to select this for our air inlet. So now that air inlet's defined. So the program can now put this into the model. However, we haven't told the program where it's going to go in the model. So you'll see here, and in use, it's not in use yet. We're gonna tell the program where it's going to go in a second. First, I'm going to define some furniture, because as we all know, furniture is very important when completing acoustic calculations. So now we have some empty seats that we can throw in a room too. So in order to put these in places, we're going to use the use units menu right here, which is just below this library menu. And where the library menu breaks down the geometrical features based on their composition. So for example, all the facades, all the partitions, or the type of feature. The use units menu breaks down the building first on a floor basis, as you see here, later on a room by room basis, and later on on the feature basis. So we can see ground floor. Let's say we go to dining room. If we open up that menu, we'll see we have walls, floor slabs, connections, and furniture. So for walls, If you look here, again, it highlights everything you have selected. So for walls, the first one is this guy, and it's selected right now, so that's why it's highlighted in the 3D menu. If you go down, you can select any wall. We want to add an air inlet to an exterior wall, so we'll add it to this guy. As you can see in the 3D menu, there's already 3 windows, and down here in this menu is where those 3 windows appear. So that's where you're going to want to add the air inlet. So we'll add that guy here. We'll just add 3 air inlets, let's say, to this wall. So now when the calculation is carried out, the program will take into account that there's 3 air inlets on this wall. However, as I said, it doesn't appear in the 3D model. So we'll add some empty seats to some meeting rooms because that would be the most intuitive thing. So let's add 10. And we can add 10 to this guy too. So now if we go back to furniture, we'll see that there's no longer an X under in use for empty seats. And same goes for air inlets. So now we're ready to calculate. We've defined all the features we need to define, and we're ready to see how our building does as far as sound propagation. So we go to this Analyze tab, we click the Analyze button, and the first thing that's going to pop up is this analysis summary. So all this is a series of histograms, and each unit in each column represents a room. So basically, if a room meets the requirement, it comes up as green. If it doesn't, it's red. But we can also see there's certain rooms that have they get the same result, but some rooms are red, some rooms are green. So some rooms meet the requirements, some don't. Why is that? Well, it's because at the beginning when we identified all the different room types, we knew that they all don't have the same requirements that they have to meet. Anyway, we know there's red and we know there's a problem, there's something we have to fix. So if we accept this, we'll look through here and figure out what we need to fix. So we'll just follow these red X's. We know there's a problem on the ground floor. If we go to Office 1, we can see we have a problem there. We look at insulation against exterior noise, and we don't have a problem there. We have a green and a check, so we're good. If we move down to the second test, the insulation against airborne noise, we can see that we're having a problem with the dining room. So it's very important to note, what's selected here on this left-hand column is where the noise is propagating into, and what's selected in this column is where the noise is propagating from. So when we select dining room, we can see it highlights itself in yellow. We know that the noise is propagating, we're having a problem with noise propagating from the dining room into this office. So we need to fix something about one of these surfaces so we have better insulation, basically. So how do we analyze that as engineers? We can look in results. If we click this button, we get a results window. The first window is just it's just this general calculations, the overview of the calculations, and it shows you your final result. We already know the final result's bad. That's not going to tell us a lot from an analysis standpoint. But if we go into the analysis table, we can actually figure out where we've gone wrong. So each of these laterals, 1, 2, 3, etc., that represent each of these columns, basically are combinations of surfaces. So the sound is going to propagate through surfaces in different combinations, and one of the combinations isn't holding up to the standard, basically, is what's happening. So we can see lateral 1, we're at 79, that's fine. 2, 102, it's fine. Here's where our problem is, we're at 50, and that's bringing our whole overall down to 50. So now we know that's where our problem is. Just for the sake of being thorough, this last tab, all it is the graph of the results on this tab. So it just helps you visualize the data. Anyway, we're getting closer to know where our problem is. We can look here, lateral 2, is where our problem is. We're in red. So it's the combination of these three walls here that you can see in the 3D menu. So we need to figure out what we need to fix about them to comply with the requirements we've set. So we'll go back over to this results menu. The first one is just the same results that were shown in the table that I showed you a second ago, and has it in graphic form. Just helps you visualize again. If we go to this analysis table, we can see it broken down a little bit more clearly for us. I'll make that a little bigger. Excuse me. So basically what we're looking at is this first column is DF, the second one's FD, and the third one's FF. So D means direct connection and F means flanking. So obviously the direct connection is going to be this orange wall as it's directly in between the two rooms, and the flanking walls are going to be this turquoise one and this green one. So when basically what this is telling us is when the noise moves into the direct wall and then into the flanking wall and then into the room, which would be into the direct wall, through this connection, into the flanking wall, and into the room, this is our result. And that's not our problem. We're at 91. The second one's flanking direct. So into this flanking wall connection, into the direct wall, and into the room. We're also at 91. We're not having a problem. We can see our problem is with our flanking connection. So when the sound moves into this wall, into the second wall, and into the room, that's where we're having the problem. So we know we need to change something about either the turquoise or the green wall in order to fix the problem we've had. And then again, the last tab is just a graph of the table in the second tab. So how do we fix this problem? We could go all the way back to the model tab and try to find this wall and try to fix it, or we can simply fix it here. You just select the paper pencil button. We can see we have our three walls listed. We know that this is a direct wall. That's not a problem. So we need to change one of these two. Let's say we change this guy. And then it gives you the wall details. So we know it's brick wall 13. We want to edit it, so we're going to click paper pencil again. And then we can edit the base element to find an element that insulates acoustically better, or we can add cladding. So that's what we're going to do here, because it's the more intuitive thing to do in this situation since there's not cladding already. And then we're going to add, let me search it. Okay, so we're going to add this type of cladding. We accept, and it's already defined. So we have to accept, and so now basically for all intents and purposes there's a cladding on the inside of this wall. However, the calculation hasn't changed. That's because you have to go back and analyze again before it's going to change. So if say we're at 49 now, we're going to calculate again. And we can already see from the histograms that we're all green, so we didn't have any problems. So we're in good shape. If we go back, we can see our number changed, 73, from 49, I believe it was. So we see that we fixed the problem. So that's just kind of a demonstration to show you guys how it's a pretty intuitive software to work with, and it can really help you solve problems. So I'm going to mention here we have results report. So this generates automatically. And all this report is basically all the information in this table in a big, long report. So you have to keep in mind that this is only for one room. So all the information for all of these rooms is in this report. And obviously the report's really helpful because it just gives you another medium to have the data in. It makes it easier if you need to send the work to a colleague, or even if you want to print it out and read through it yourself physically. It can help you absorb the information better, obviously. You can export the report to PDF, docs, or HTML format. So that's all about that. We're going to show you one more thing, just to, for the sake of showing you guys how effective BIMserver.center can be in moving and transferring data, and also how sensitive this program can be to changes. We're going to change something in the IFC file, and then we're going to update this file so it reflects that change, and then we're going to update the analysis and show you guys how everything changes. So I want you guys to pay attention to this window right here. We're going to change this in the IFC file. So I'm going to open up the IFC file again. I'll show you guys in the 3D view here. The window's the same. This is the window in question, right? This guy. So we're just going to change that to a different type of window. You guys might have been able to see that line just got longer, just representing that the window got wider. We can look at the 3D view again and see that the window did indeed change in the 3D view, or in the IFC file. Now, we need to put it in to BIMserver.center, so we're going to have to export this file again. It's already linked to the example that we're working in. So it's exported. So now when we open up AcoubatBIM again, when we go to the Model tab, you can note in the upper right corner, now this update button is blinking. And so that's telling you that AcoubatBIM has recognized that something in the IFC file has changed that's not being reflected in the current version you're working on. So it's telling you if you want to be working in the newest version of the IFC file that's registered in the BIM server, you need to update it. So we'll go ahead and update. As you can see in this 3D model, the window changed, and we accept. We'll look back at this 3D model, and you'll see the window changed. So now we'll see how that affects our results. So right now, as I said before, the results don't change because we haven't pressed the Analyze button yet. So this is on the 4th floor in this office. We can see the windows in that room. Obviously, it's going to be a problem with the external noise because it's an external wall. It's an external window. So we're going to find which surface the window is on. This guy, and we're going to select the window. So we can see right now our calculations have kicked out 44 as a result, right here. So if we analyze again, so again this analysis is for the new window geometry, and we go back and find the window again, we can say it changed to 38. So it just shows you how sensitive the computational engine can be. It's a pretty accurate system. That's all we have to share with you guys right now. If you guys have questions, please just type them in the chat, and we'll respond the best we can. We want to thank you guys for joining in and listening to us today. Yeah, just thank you guys very much. And again, if you have questions, just feel free to ask.